All right, we're going to take a break from our previous lessons in writing or in figuring out whether triangles are congruent to each other or not. And we're going to start to set up for the proofs, the formal proofs that we're going to write. So our formal proofs are written in as a two-column proof. Every two-column proof has a statement on the left-hand side and a reason for that statement. The statement is what we know, and the reason is why we know it. We are going to continue. In fact, we have been doing these all along, right? We would go through and I would say, this is congruent to this. Why? Because it was given. This is congruent to this. Why? Because it was given. This is congruent to this. Why? Because vertical angles are congruent. And then we could say the triangles were congruent by angle, angle, side. That is a proof. That's what we've been doing all along. Now we're just going to start putting that into actual writing. So we're going to baby step it, and we're going to start with just some standard vocabulary stuff that's going to come up a lot when we're doing these proofs that you want to be aware of and watch for. So the first thing is you're going to always be given some information. That's the stuff that we know because I told you so. Then the rest of it is, what do we know because of that? So the first statement says that DB bisects angle ADC. So here's a couple of things you need to remember. DB is a segment. It bisects an angle. So bisect means it cuts in half, and we've cut an angle in half. Okay, so we go over here and we say, okay, well, DB bisects angle ADC. So here is angle ADC. It's right here. And DB bisects it. What that means is we just cut an angle in half. When you cut an angle in half, you get two congruent angles. The two congruent angles are the angles that are at the actual, we take the whole big angle and we cut it in half. We cut it into two equal pieces. So what that tells me is that angle 5 is congruent to angle 6. Why? Because that is what an angle bisector does. And so we would say that is the definition of angle bisector. That I know that if DB bisects an angle, the result is going to be two congruent angles because that is what an angle bisector means. Right? So whatever our first statement is usually our reason for our second statement. What is the result? What happens when I cut an angle in half? I get two congruent angles. Okay, let's look at another one. So another one, it says that angle 3 is congruent to angle 4. So we go over here to our picture and we look. Angle 3 is congruent to angle 4. Well, why is angle 3 congruent to angle 4? It's true, angle 3 is congruent to angle 4, but why? Well, angle 3 is congruent to angle 4 because they're vertical angles. And vertical angles are always congruent. Vertical angles are congruent. Now, when you are doing these, they're going to be in a drop-down menu and you're going to get to choose, but you need to know what to choose. What is the result of what we have? Angle 3 is congruent to angle 4 because vertical angles are always congruent. We know that as the definition. Okay, again, let's look. B is the midpoint of AC. Again, here we've got a vocabulary word, midpoint. It is the midpoint of a segment. So let's go look. So B is the midpoint of a segment. Well, when I have the middle of a segment, you have to learn to isolate your picture. When I have the middle of a segment, the result is two segments. Which two segments? Well, it said the middle of AC. That means, right, that means that AB, what parts are congruent? That's the part that goes in our statement, is what parts are congruent. So that means that AB is congruent to BC. Why? Because B is in the middle. And that is the definition of what the middle point does. That is the definition of midpoint. Because I have a midpoint, I know that AB is congruent to BC. In our statements, we're always looking for a part congruent to a part. That is our ultimate goal, is part is equal or congruent to a part. Okay, so we've done angle bisectors. Angle bisectors result in congruent angles because that's what angle bisectors do. Vertical angles are always congruent. Midpoints result in congruent segments because midpoints are in the middle of segments. It breaks them into two equal pieces. So let's look. BD is congruent to BD. Let's look at our picture. Why would we know that BD is congruent to BD? We talked about this the other day. BD is congruent to BD because it is the reflexive property. It is a reflection of itself. This is what it would look like. BD is congruent to BD because of the reflexive property. And so we would say right here, BD is congruent to BD because that's what it means to look at its own reflection. That's going to be equal. Okay? Now, 2 is congruent to 4. Let's look at our picture and figure out why 2 is congruent to 4. So I'm going to mark it. It says that 2 is congruent to 4. So I look at that picture, and what I notice about that picture is I see these arrows right here. Remember what those arrows mean? Those arrows mean that those lines are parallel. And here's what I know. If I draw those in, if I draw in those parallel lines, and I connect them with that transversal, what I notice is that angle 2 and angle 4 are alternate interior angles. So the theorem says this: if lines are parallel, which I told you in the picture they were, right? That's what those little arrows mean. If lines are parallel, then alternate, I'm going to write the whole thing out here, but you will be able to shorthand it. Alternate interior angles are congruent. That goes back to our previous unit where we talked about that. I know that the lines are parallel because the picture says so. If the lines are parallel, that tells me that this angle 2 is congruent to this angle 4 because those are alternate interior angles. And if the lines are parallel, I knew the lines were parallel from the picture. If the lines are parallel, then the alternate interior angles are congruent. Now, let's put this together and let's write some really little, really straightforward, basic proofs, okay? So you are going to be always given some information and you're going to be trying to prove something. So I have been given that OC is congruent to OD, angle CAT is congruent to angle DOG, segment AT is congruent to segment OG, and I want to prove that triangle CAT is congruent to triangle DOG. When you are trying to prove triangles are congruent, your reasons always have to be, okay, to prove triangles are congruent. Remember, this was our summary the other day. Side, 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 angle, side, HL, angle, side, angle, or angle, angle, side. Those are our 5 options, okay? That's it. So your first statement, you're given is always going to be the first thing. So I know this because it says so. This was given information. This is not given information. It's what I'm trying to prove. Okay? It's what I'm trying to prove. This is the evidence, right? This is what we know, and then this is what we're trying to prove. So I know this because it's given. So let's go up. You always want to go and mark everything. So this is where it ties to what we did before. I know that AC is congruent to OD. That was given information. AC is congruent to OD. So just like we did before, I'm going to mark it on one picture. I'm going to highlight it. AC is congruent to OD. It says CAT, this angle, is congruent to DOG. Those two angles are congruent. So then I'm going to highlight those two pieces whenever they have a match. Remember how we highlighted them. And then it says AT is congruent to OG. AT is congruent to OG. I always mark, remember I highlight my matching pieces. So I have 3 pieces now. I have 2 sides and an angle. The question is, are they the right sides? Okay. is the angle included? Well, I have two sides and an angle. I'm never going to give you one that can't be proven, by the way. So then I can say that these two triangles are congruent because of the side, angle, side theorem. Okay? So based on all this given information, I know that these triangles are congruent by side, angle, side. This is the exact thing that we did a minute ago, right? Or not a minute ago, we did previously, but I had it marked in the picture already, and you had to make the side, angle, side, angle, that kind of decision. You had to choose between these five, okay? So this is how it looks with a two-column proof. So let's start here. We know this is our given. Let's just start up here. Don't even look here. Just mark what we know. AMT, so AMT is right here. This is why it's important to know how to name angles, is congruent to HTM. HTM. So I'm going to mark those two congruent. I'm just marking everything, right? I'm just marking it, what's congruent, so that I can see it in my picture. And then angle A is congruent to angle H. So I'm going to start there. Okay, here's what I'm going for. I want to prove that this triangle is congruent to this triangle. So that's what we did the other day. I asked, are the triangles congruent and why? So that's what I'm trying to get to. Now, we always start with what we knew, right? Why do I know that AMT is congruent to HTM and angle A is congruent to angle H? Because it says so right here. It was given. Your first statement will always be your given statement. Okay? Now, the next statement says MT is congruent to MT. So I'm going to go up here and I'm going to mark. Let me just mark these things that I already have. I'm going to highlight one of them. I have this angle and I have this angle. Ignore this one. I didn't mean to do that right there. Ignore that. Okay? So I have all of that. That was given. So I'm just highlighting what I have there. Then look at this statement right here. It says that MT is congruent to MT. So I'm going to go up here and I'm going to mark it. MT is congruent to MT. And anytime anything has a matching pair, I highlight it. So the question says, why is MT congruent to MT? Well, MT is congruent to MT because of the reflexive property. So we would write reflexive right here, reflexive property. So at this point, I have an angle congruent to an angle. I have another angle congruent to an angle. And I have a side congruent to a side. So I have two angles and a side, so I'm allowed to stop, but now I have to decide. Is it angle, angle, side, or is it angle, side, angle? Those are my two choices. Let's go back up and look at our picture. Remember, this one's not actually here, right? That line's not actually there. So notice that MT is touching M, but it's not touching A. Okay? So in order for it to the side to be included, the other angle would have to be over here at T. It would have to be sitting right here. They both have to be touching the segment for it to be included. So I have this angle here, I have this angle here, and I have this one. So I have MT and M, and then I have A. It's not touching both sides, so it's not included. And so I use the not included one, right? That's angle, angle, side. So these two triangles would be congruent by angle, angle, side. Go off of whether it is included or not. Let me take this out so it won't be confusing when you look at it. Okay, so this piece right here. No, I kind of got rid of that extra line I didn't want you to see. I want you to see how they're not included. Okay, so that's how it always works. So let's go back over here. Okay, let's start with our given. So our first statement, we were given that RA is congruent to AY. So let's mark that. RA is congruent to AY. Okay? Then it says that A is the midpoint of CZ. A is the middle of CZ. That means that AC is congruent to AZ. Okay, all of that was from here. So let's go look. Why do I know that RA is congruent to AY and A is the midpoint of CZ? Just like always, I know because I told you so, because it was given. Then we say, okay, why do I know that CA is congruent to AZ? Well, why did I mark those two congruent? Because that's what midpoint means. Y'all, our goal is to always end up with congruent sides and congruent angles. Here we have congruent sides, right? If you have a statement that doesn't say something is congruent to something, like specifically like this says this side's congruent to this side, this statement will always result in either congruent sides or congruent angles. In this case, A is the middle, so it's going to result in congruent sides. Why? Because that is the definition of midpoint. Midpoint means it's in the middle of the segment, which means those two segments are congruent to each other. Okay, so far, here's what I have. I have this segment is congruent to this segment. I have this segment is congruent to this segment. Let's look and see what it says next, and let's figure out why. It says RAC is congruent to ZAY. ZAY. I've used up all of my, everything like this resulted in this segment, so we're done with that. So why would I know that RAC is congruent to ZAY? It wasn't in my given statement, but why would I know that? Oh wait, those are vertical angles, and we know that vertical angles are congruent. So I know that this angle here is congruent to this angle here. Vertical angles are congruent. And that gives me an angle congruent to an angle. As soon as you have three pieces of good information, because the question is the angle included? Because SSA doesn't work, right? So let's look. The possibility, it could be SSA, which means I need more information, or it could be SAS. The angle is included in between those two congruent sides, which means then that these two triangles are congruent because of side, angle, side. Okay? Our goal in every proof is to end up with sides congruent to sides and angles congruent to angles. So we are simply writing down each of the steps that we went through the other day when we were trying to say that the triangles were congruent. We start with our given information. We use the pieces that we know to get congruent sides and congruent angles. And when we run out of our given, we go and we look at the picture and we see what else we know. I know that these two angles are congruent because those two are vertical angles, which means that then we can use one of our 5, side, 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 angle, side, HL, hypotenuse, leg, angle, side, angle, and angle, angle, side to prove that our triangles are congruent. And we'll get more into this later.